Hello everyone. In this video I will talk about the Kruskal's algorithm. Kruskal's algorithm is one of the methods to find the minimum spanning tree of a undirected connected graph. While we discuss the Kruskal's algorithm, we have to keep two things in mind. We are going to create a tree, so a tree will not contain any cycle. And the second point is, if we have v vertices in the graph, there will be v minus 1 edges in the minimum spanning tree. And that's being said, let's look at the steps that we need to carry out to run the Kruskal's algorithm. The first step is we have to sort all the edges of the graph in the ascending order of their weight or cost. Okay, so we have to create a list where we will be listing the smallest weight at the first and the highest weight at the end of the list. Okay, and in the second step, we have to pick the smallest edge. So we will be picking the first element of the list and check if it forms a cycle with the spanning tree formed so far. If a cycle is not formed, include that edge in the spanning tree, otherwise discard it. And repeat these steps until we have v minus 1 edges in the spanning tree. So I have taken an example here to run the algorithm. Rather than showing the formal algorithm, I'm just showing the steps here. When you list the edges in the ascending order of their weight, we will be listing in this particular graph, for instance, v1 v4 will be the first edge because it has got a weight of 1. Similarly, v6 v7 will be the second edge because it has got a weight of again 1. Then we will be listing v1 v2 and v3 v4 etc. The convention when we write the edges is we'll be writing the smallest edge first, then the second edge. So we'll be writing v1 v2 rather than v2 v1. Both of them are the same, but we follow that convention. Okay, now here I have shown a table which lists the cost and the edges in the ascending order. I'll be utilizing this table in order to run the steps. We will be filling this column in order to indicate that whether an edge is accepted or not. So let me take this graph a little bit down. While we run this algorithm, we have to keep track of the number of edges. Okay, so here we have v is equal to 7. So we can have v minus 1. This will be equal to 6. So we can have maximum 6 edges in our spanning tree. So let's start the procedure. The first edge is v1 v4. I can take the edge v1 v4 because it doesn't create any cycle, because this is the first edge that we are going to select into the spanning tree. So this edge v1 v4 can be selected. So the number of edges that we included so far is 1. So this is selected. Next one is v6 v7. This is v6 v7. So this is also selected. So the number of edges is 2. So this is also selected. And next one is v1 v2. So this is v1 v2. This can also be selected because it doesn't create a cycle. So the number of edges selected so far is 3, and this is selected. Next one is v3 v4. This is v3 v4. That can also be selected because it doesn't create any cycle. So the number of edges selected so far is 4. So this is also selected. Okay. The next one is v2 v4. v2 v4 is this one. If you select this one, I am just indicating it with the dotted line. If you select this one, this is going to create a cycle over here, so I will not select it. So that edge is rejected. Next one is v1 v3. This is v1 v3. If you select it, it is going to create a cycle over here, so that is also not selected. Okay, so this is not selected, this is rejected. Next one is v4 v7. This is v4 v7. That can be selected because it doesn't create a cycle. So the number of edges selected so far is 5, and this is selected. Next one is v3 v6. This is v3 v6. If you select that v3 v6, then this is going to create a cycle over here, so this is also rejected. Next one is v5 v7. This is the edge v5 v7. We can select it because it doesn't create any cycle. So this edge v5 v7 is, so this edge v5 v7 is selected. So the number of edges selected is 6. So we can end the procedure over here because the number of edges has become v minus 1. Okay, so this is the minimum spanning tree. So you can see that we have connected every vertex using the minimum cost. If you sum up the edge cost of all the edges in the spanning tree, you will get the total cost. Okay, that will be minimum. So we have selected this one as well, v5 v7. So you can see that we have selected 6 edges and when we have rejected all the other edges. Okay, so this is how we make a minimum spanning tree using Kruskal's algorithm. I hope the steps are clear. Thank you.